it's all about hydrogen and hydrogen fuel for cars. Right, this one, there is a large amount of information here. Now, I'm going to say something a little bit reckless now, but if this was me and I had all that information, probably what I would actually do is have a quick glance at it and then go, right, okay, what am I actually trying to find out? So, do it there a second. If I find the other part of this question, which is probably over here somewhere. Nice. Right, so what am I actually trying to find out? It says, get rid of that. It says, hydrogen is produced at the negative electrode during the electrolysis of potassium hydroxide solution. Okay, if you say so. Why are hydrogen ions attracted to the negative electrode? Right, classic bit of a chemistry or even science question here. That question, don't even need that bit or any of this to answer it. Right, so sometimes you can save yourself a lot of time is by going to the question and then just going straight in. Now, if you're not obviously sure what the answer is, there is a good chance that it might be something you can find in the text. But in this case, hopefully you are all good enough to realise that if hydrogen ions are attracted to the negative electrode, two things here. Number one, you should know what a hydrogen ion is. And number two, even if you don't, if it's attracted to the negative electrode, it clearly must have a positive, that's as they have a positive charge. And that will get you your answer. Easy peasy. Right, okay, so next one. It then says potassium ions are attracted to the negative electrode. Okay, fair enough. Explain why hydrogen gas is formed, but not potassium. Okay, now this is, again, synoptic stuff. Back to the wonderful world of electrolysis. So you are expected to know if you have something in solution, so water is there as well, then water contains hydrogen ions and hydroxide ions. And of course, if you've got something dissolved in that water, then you are going to have a possibility that either hydrogen goes here or potassium goes here. So the rule for positive ions is that if the ion is more reactive than hydrogen, it stays in solution and you get hydrogen gas. If it's less reactive than hydrogen, then that metal will go instead of hydrogen. So basically the more reactive one stays in solution. All right, so why hydrogen gas is formed but not potassium? It's because potassium is more reactive than hydrogen. Of course, you might remember the ones that are less reactive that you need to know about are copper and silver and gold. Gold, not that, 1+. Right, okay, so that's that one. So that, again, that's nothing really to do with the text. Then there's some stuff here about just balance this equation. Okay, so this one, what do we got here? We've got lithium, N2, and then Li3N. Right, so tempting first of all to put a 3 here to get that balance, but of course, because there's a 2 there, you're going to need to put something in front of here to get 2 here. So it makes sense really to balance your nitrogens first. So that 2, remember that 2 means 2 times all of that. That then gives us 6 lithiums, so therefore we are 6, like that. Right, okay, so we're into the kind of realms of a little bit more equilibrium-y stuff now. So you can see we've got a reversible reaction here. The equation for the reaction of lithium nitride with hydrogen is blah. What feature of this reaction allows the hydrogen to be released? Right, if you've got hydrogen being released, that would normally be because it's one of the products it's being made, but it's not. So how on earth can you get hydrogen? Well, you can get hydrogen, of course, because as well as this reaction can occur, you can get this reaction occurring. So the reason that that can happen is because the reaction is reversible. Right, okay, so that's that bit. If I scooch that up a bit. Right, so the hydrogen stored in a fuel tank filled with the lithium nitride would be safer in an accident than if it was just full of hydrogen. Okay, now I think there's a little bit in the text about this, but again, I wouldn't be at all surprised if your knowledge is good enough that you don't actually need to go there. So if you look at the previous question, it obviously tells you that oops, where's it gone? There it is. The hydrogen reacts with the lithium nitride to produce these two things here. Okay, so if the hydrogen is actually joined with this or bonded with it, then clearly it is not a free gas, and therefore it's unlikely to basically catch fire or explode, which that's what hydrogen does. So your first mark is for realizing that the hydrogen bonds or reacts with, all right, the lithium nitride, or if you like, let's just copy the formula. That seems like a good idea. All right, so they bond together. Why is that important? Well, you are expected to know that hydrogen, if you think back to your squeaky pop test, it works because hydrogen is explosive. Obviously, that's very small amounts. Clearly, large amounts are going to be bad news. Right, so that stops, right, the hydrogen exploding. So less chance of explosion. All right, or it doesn't explode. The other thing you could talk about is, because of course this stuff is a gas, we're going to have lower pressure as well. All right, so you could put that there will be less pressure, which of course would reduce the chance of explosion as well. Right, and that will get you 2 marks. Okay, is there any more to this one? Don't know. Where's it gone? Oh yeah. Right, so lithium nitride is an ionic compound containing lithium ions, Li+, and nitride N3- with a bracket on the next line for no reason. Right, formation of lithium ion from a lithium atom is an oxidation. Ah, yes. Right, so it's good old. Yay. What does that even mean? It means oxidation is loss of electrons. There you go. So if you think about a lithium ion, lithium atom, just a little reminder, is lithium. It's in group 1. There it is. Ooh, there it is. So when it forms an ion, it loses an electron and becomes positively charged. So therefore, right, it is oxidation. Right, then we've got some pretty pictures. There's a nitrogen atom, 2 electrons, 5 electrons. Complete the diagram to show the structure of a nitride ion. Right, ions will always have a full shell of electrons. If it's got a 3-, it means it's had 3 electrons added to it. So basically, there's your atom. All you've got to do, copy the atom, there it is, and then add 3 more electrons. Let's stick them as dots because we're good students. There we go. Right, so there is your marks for that one.